And welcome to the second half of the College Algebra Semester Test Review, starting with question number 18. So here we're solving for x, where x is in the exponent. So I want to get rid of everything that's not with the exponent. So I'm going to subtract 4 right away. So I would get 3 to the power of x minus 1 equals 4. And from here, because I'm trying to get rid of this base number, I'm going to spiral it with a logarithm. So I would get log base 3 of 4 equals x minus 1. Of course, I can just add 1, and I can type this whole expression right into my calculator. So remember, if I press the log button, I can't change the index number, so I'm going to go to math, down to A, log base 3 of 4 plus 1. And I would get about 2.26. 19 divide by 25, divide by 25. We get 2 equals e to the 0.04x. We can't spiral it. Now, when I spiral with e, that's actually the natural log, because e and natural log are inverses. So I can divide that by 0.04. So I get about 17.33. Okay. Number 20. Just like the opposite of what we're doing here, I can spiral right away. So I get 2 to the negative 1 equals x minus 9. So I can just add 9 to both sides. 2 to the negative 1 plus 9 gives me 9.5. Because if you remember, a negative exponent just means it goes to the denominator. So that's really just saying 1/2 plus 9. 21. So I'm going to do something similar to 20, where I'm going to spiral, but I have to get the logarithm by itself first. So the first thing I would have to do here is divide by that 3. So I get the natural log of x minus 2 equals 1/3, and I'm going to spiral. Just like in number 19, when I'm using natural log and I'm spiraling, I'm going to use the e. So I get e to the 1/3 equals x minus 2, so I can add 2 to both sides. So I can just type e to the 1/3 plus 2 right into my calculator. E is second ln. So I would get something like 3.4. Okay, 22, I am adding the logarithms, so I can put them together and multiply the insides. So I can distribute that. So you get x squared plus 5x and natural log of 6x. Because I have natural log on both sides, I can do e to the power and cancel it out. So I know that I get x squared plus 5x equals 6x minus 6x minus 6x. X squared minus x equals 0. And I have to factor this. So I get x times x minus 1 equals 0. And I can set both of these equal to 0. So my potential answers are x equals 0 and x equals 1. Well, as it turns out, one domain restriction issue is whatever I have inside the logarithm has to be greater than 0. So for example, if I plugged in this 0 into this first natural log, so if I did natural log of 0, I actually get an error. So you can't do that. So 0 is actually extraneous. So the only answer for this one would be x equals 1. #23, solve the linear system. So a couple ways you can go about doing that. You can do by systems of equations. You can solve by elimination. You can solve by substitution. You can solve by graphing, or you could go into matrices. I'm more partial to elimination here, especially when I see that the x's are pretty closely together. I can just multiply this bottom one by -3. So then I would get positive 6x plus 6y equals -6. And if I don't change the first one at all, I can combine these two together. My x's eliminate. -5y plus 6y gives me just y. 5 minus 6 gives me -1. So I get a -1 for the y. With that, I can take that value and plug it into one of my two original equations. It doesn't matter which. For the sake of argument, I'm going to pick the first one. So I get -6x plus 5y, plus 5 equals 5, minus 5 minus 5, -6x equals 0, divided by -6, divided by -6. We get x equals 0. So my answer as an ordered pair would be x 0, y -1, so 0, -1. 24. 2 cheeseburgers, I'm going to call cheeseburgers X, and 1 small order of fries, I'm going to call fries Y, contain a total of 1460. So I can get 2x plus y equals 1460. 3 cheeseburgers, again, cheeseburgers is X, and 2 small orders of fries Y contain 2350. So 3x plus 2y equals 2350. Again, this is just systems of equations problems. The same methods would still work. I'm going to do elimination again. So I'm going to multiply the first one by -2. That way my y's are equal and opposite. So -4x minus 2y equals negative. -2920. And 3x plus 2y equals 2350. I can combine those together. So I get -x equals -570. I'm a negative, we get x equals 570. And I can plug that into one of my originals and solve for y, just like we did up here. We get y is 320. So it's a 570 and 320. Determine the dimensions. Dimensions are always height by length. So this would be a 1/4 matrix. Height by length, this is going to be a 2/3. Height by length, this is a 3/4. Height by length, that is a 3/2. Evaluate, so I would do 2a first. So I'm going to do 2, I'm going to distribute it to every single element here. So this is going to be 1 times 2, which is 2, 4 times 2, which is 8, 3 times 2, which is 6, 2 times 2, which is 4. Now I'm going to add it onto the B matrix. So -3, -2, 4, 2. One thing to check quickly, what do you need in order to add or subtract matrices? They have to be the same size. So both of these matrices, importantly, are 2x2s. So I can add them. You just add corresponding pieces. So 2 plus -3, which is -1. 8 plus -2, which is 6. 4 plus 4, which is 8. 6 plus 2, which is 8. And then I'm going to multiply it, because that's what I got right here, times the C matrix, which is 4, 3. Now, this matrix is a 2 by 2. This matrix is a 2 by 1. Shoot. So the first thing I would check is, can I multiply them? I can, because those numbers match. And of course, we can see that 2 by 1 is the result matrix. Remember that anytime I'm multiplying, it's always row times column. So I'm going to get negative 1 times 4 plus 6 times 3 over 8 times 4 plus 8 times 3. So that gives us 14 and 56 as our 2 by 1 matrix. A license plate has 3 letters followed by 4 single-digit numbers. How many different license plates can you make if they can be repeated? Well, in the first spot, undo, I could have 26 letters. If I can repeat the second spot, I could also have 26 letters. And the third spot, I could have 26 letters. In the first spot for numbers, there's 10 single-digit numbers because you have 1 through 9 and 0. And if I can repeat them, I can get 10 for the other spots. To find all the possible combinations, that's just the fundamental counting principle, which just means I multiply all these numbers together. So I would get 175,760,000. Okay. 30 members of a club want elected president, a vice president, and a secretary. How many different ways can this be done? So this question is all about asking, if I'm going to choose some things, does the order matter? Well, in this case, I'm selecting 3 spots. And if I'm selected first, or if I'm selected second or third, my responsibilities would be different. So because order matters, this is a permutation. Okay. The first number in a permutation is how many I'm picking from, so 30 in this case. And the second number is how many I'm picking. In this case, I'm picking 3. So I get 30p3 in my calculator, which can be found under math probability. So we'd get 24,360. 30 members of the club want to elect a 5-person social committee. How many different ways can this be done? Well, if I'm selected first, second, third, fourth, or fifth, I'm still part of the committee, so the order doesn't actually matter. So that would be a C, and I would have 30 I'm picking from and selecting 5, so 30C5. So I would get 142,506. 30. There are 30 marbles in the bag. 7 are green, 12 are blue. The rest are red. So I know red would equal 30 minus 7 plus 12. So there has to be 11 red marbles. What's the probability that a red marble is selected? Well, that'd be 11 out of 30, which as a decimal is 0.36 repeating. But if I move it over twice for percentages, I get 36.6 repeating, or effectively 36.7%. There are 30 marbles in the bag, 7, so same bag, the rest are red. Probability that if I select 2 marbles, that 1 is green. Well, there are 7 green out of 30. And that the other is blue. Well, there are 12 blue marbles. However, if I'm grabbing 2 marbles at once, the green marble is already out of the bag. So how many marbles are still in the bag? It'd be 29. Just like if I go back a slide here, on here, if I could not repeat these, this 26 would turn into 25 right here if I can't repeat letters, or this 10 would turn into 9, 8, and 7. So be very careful on what's being presented. Now, if I have two equations like this, I would have to multiply them to figure out the probability, because that's called conditional probability. So I get 7 times 12 up top over 30 times 29 on the bottom, which is 14 over 145, or about 9.7%. There are 30 marbles in the bag. 7 are green, 12 are blue, rest are red, so same bag as earlier. What's probability that it's selected? It is either red or green, so I'm only selecting one marble. Well, 11 of them are red, and 7 of them are green. Technically, I don't care which I get, so I can actually add those numbers together. Let's get 18 out of 30, which simplifies down to 3/5, or 60%. There are 30 marbles in the bag, same bag. What's probably that I select any color but green? Well, I have 7 green ones. So any color but green, I can just subtract from 30. So I get 23 out of 30 aren't green, which gives me, 76.7%. Okay. Solve for A. A is right here. Thankfully, it's a right triangle, so I can use SOHCAHTOA from the perspective of A being my theta, 6 is my opposite, 14 is my hypotenuse, which trig ratio uses opposite and hypotenuse. That would be sine, so I get sine of A equals 6 over 14. So I get sine of the -1 of 6 over 14, which I can type directly into my calculator. If we're doing inverses, I can do second. So in this case, second sine of 6 divided by 14. So I get 25.38 degrees. Okay. Over here on this triangle, I'll notice I don't have a right triangle, which means I'm either going to have to use law of sines or law of cosines. Remember, law of sines comes up if I have a pair. Now, I don't technically have a pair yet, but because I have two angles, I could find the C angle. So C is an equal 180 minus the sum of 76 plus 34. 76 plus 34 would be 110. So I know that C has to equal 180 minus 110, or 70. So if I put 70 in for C, I'll notice I now have a pair. I have big C and little c, which means I can use law of sines here. So I can do sine of big A, so 76, over little a, has to equal sine of big C, or 70, over over little c, which is 9. We can cross multiply, so I'm going to get 9 times sine 76 equals A times sine of 70, and then I can divide by sine of 70. And I can type this whole thing right into my calculator. Now, seeing that sine of 70 degrees is big C and little c is 9, and that big A was 76, I should get a number bigger than 9 because triangles are proportional. So if I don't, I know that I made an error somewhere. 9 sine of 76 divided by sine of 70. you get about 9.29. Okay. Thank you for listening, and I hope you have a great day.